Exponents, applications. Before solving equations that contain metric prefixes, we first need to change values with metric prefixes to a value with a power of 10. So let's look at the first example. Find the capacitive reactance value of a 200 nanofarad capacitor at a frequency of 15 kilohertz. Use the formula below where we have Kc is measured in watts, F is measured in hertz, C is measured in faradays. So when we go ahead and plug in all these things that we've done before, we would get a new equation that looks like this, rather than putting 200 or 15. And the reason why is because we all have to have the same value of all the numbers, because if you put in just 200, it would greatly skew the solution as it would not be correct. So we have to get it all into the same. So it's just Faraday at the end here would just become Faraday, and this would just become hertz, as this is just in watts. So now we can go ahead and solve for this. So when we go ahead and solve, we can just go ahead and leave this 2 pi for right now. And then we have, when we deal with this, we can look at just this first. So we have 15 times 200 times 10 to the third, 10 to the negative ninth. Those are multiplied together. Then this can be broken down into 1 over, so then 2 pi, still 15 times 200, and we get 3,000. Now times 10 to the 3 and negative 9, so in order to combine those, we'll just add them together. So 3 minus 9 would be 10 to the negative 6. And so now we have it set up. Let's now go ahead and go. First, let's convert this now into just a regular number. Standard notation. So what we can do then is keep 2 pi. We'll just do this off to the side. Now 3,000. We have a decimal right here. We need to move it over 6, and it's to the left because it's negative 6. So we'd go 1, 2, 3, 4, 5, 6. So then our new number in standard notation would look like 0.003. And so now we can get our calculators out. We can go 2 times pi times 0.003, and we get 0.01885. We'll take it a little bit further. So 0.01885. Now we go ahead and go 1 divided by 0.01885, and we get 53.05. So then our final value, as this is equal to 53.05, is 53.05. And when we go back, we know that it's measured in watts. So that would be our final solution. Now let's do another example. Example 2. Find the capacitive reactance value of a 200 nanofarad capacitor at a frequency of 1.5 kilohertz. Now we're going to use the formula below. And notice that we've already converted our metric prefixes into the formula, as this is equal to K subscript C. So now we've all had to set it up. We're going to go ahead and go ahead and start calculating this out. So we have 1 over, we're going to keep 2 pi off to the side. So what we can do is multiply these two coefficients together. 1.5 times 200, we'll go like that, and then it's times 10 to the, we have third again, and then 10 to the negative 9th. Those are multiplied together. Now let's go ahead and get our calculators out. We have 1.5 times 200, so we get 300. We have 1 over 2 pi 300 times 10 to the, before we just added these together, so 3 and negative 9, so that's negative 6. Now we can go ahead and convert this into a number. So we're going to go this way now. So we have 1 over 2 pi still. And now let's look at 300. We have a decimal here. We need to go over 6 spots. So let's make room for over here. We go 1, 2, 3, 4, 5, 6. So this new number, instead of saying 300 times 10 to the negative 6, in standard notation is 0.0003. Now let's get our calculators out. So we are going to go ahead and go 2 times pi times 0.0003, and we get 0.001885. So we get 1 over 0.001885. And then when we go ahead and divide, we go 1 divided by 0.001885. And we get 530.5. And this is in watts.